Section 8.1 notes, reciprocal and Pythagorean identities. We are now doing trig identities. So this section is, it's a proofing kind of thing. Make sure that when you're doing these, take your time, give yourself plenty of space. It's not always long. Questions, and some are short to get the answer. It's not quite like geometry proofs, but the idea of just kind of looking at a problem and trying to rewrite it to simplify is pretty much what you're doing. So make sure that you just have a positive, open mind about it, and that way you're able to just focus and concentrate. You will have to memorize, so make sure that you are doing that as we go, and I'll point that out. So the first thing I want to do is kind of remind us about the definitions of sine theta, cosine theta, and tangent theta in terms of x, y, and r. We did this in our last section, unit 6. And so what I did is I drew this circle over here, this unit circle right here, and I wanted to kind of remind you of, here is what we did. We drew a right triangle, and we were able to find what theta was. And this is the unit circle. So using the unit circle on here, this is what's helping us to solve these problems. Okay, so when you were trying to find sine theta, you know it was always the opposite over the hypotenuse. And if we were to look at this triangle, the triangle in the circle that we drew in the unit circle, we would know that that equals to y over the hypotenuse, which is r, and that just equals y, because we knew the radius was 1. The unit circle, the radius is 1. So remind ourselves that. Okay. So now let's just use the same idea with cosine. So the cosine was adjacent over our hypotenuse, and that equals your x over your r. And we said that just equaled x because the unit circle, our radius is 1, so r is 1. Now tangent is the opposite over the adjacent. So that just gave us our y over x. Notice that there's no r in that. But I want to go back. Instead of using, this is x. Instead of using x and y, let's use sine theta and cosine theta. So tangent equals, if we have y on top, that's sine theta. We did talk about this in the last, when you used your definitions here, but might have forgotten. Okay, so now tangent equals sine theta over cosine theta. Just to kind of make sure we know that, remember, theta right here is just the angle. We used it x in the last unit when we were graphing the trig functions. Remember, it's the variable. It's whatever that angle is. So we can use theta. So usually when we use this, we use theta. Sometimes we use x. Sometimes we use u. In calculus, when you do this, use this for calculus, you would use u at times for substitution. So it doesn't matter what the variable is, as long as you understand that theta is just a variable and we treat it just as such. So let's go to the next 3 questions. Which trig function is the reciprocal of sine theta? Well, sine theta is the same as cosecant theta. Secant theta goes with cosine. That's the reciprocal of cosine theta. And then tangent theta, the reciprocal of that is cotangent theta. So these we learned from the beginning of trigonometry. So now what we're going to do is we're going to look at these identities, and we're going to put them in this little box here. You must memorize these. These are not, will not be given to you. So you have to know them. So I'm just going to highlight this box so that we can show that, okay. There we go. So now let's look at the reciprocal of sine theta. The reciprocal of sine theta we know is cosecant theta. And so if you think about that, let's go over, cross over the reciprocal of 1 over cosecant theta. That means the reciprocal. That is sine theta. Next one, reciprocal of cosine theta is secant theta. I seem to have lost a letter up here. Let me rewrite this, sorry. And the reciprocal of secant theta, is cosine theta. Okay, tangent theta. So the reciprocal of tangent theta we know is cotangent theta. I'm just going to go across. Well, the reciprocal of 1 cotangent theta is tangent theta. So now remember that. So this is not a reciprocal identity, but this is one that we use that'll help us with this one. So sine theta over cosine theta, we know we just learned is tangent theta. And if you take the reciprocal of that and put cosine theta over sine theta, that is going to be cotangent theta. So pay attention to these two right here. We're going to use those a bit as well, pretty much all of them. But knowing this, what's in here will help you with what we're doing. Again, memorizing these and so forth. So we're going to do some more identities. So first we're going to do this thing here. It's asking us to convert the following to x, y, and r and simplify. Okay, so it's time to convert the following x, y, and r and simplify to this here. What does that equal to? So what I'm looking at here is I'm going to look at my little triangle here. I took it from up here, so I'm going to use this unit circle up here. Okay, and I'm going to use that information to help me to find this identity here. So we know that this is a right angle. Okay, we know that this is theta. So we always go what's opposite of theta is your y, and adjacent to your theta is always your x, and the hypotenuse is r. So we're going to use that information to help us to find this. So this is Pythagorean theorem if you think of a right triangle, okay? So I know that I can write this to solve for r. R is we know that from that. So from the unit circle, though, like we said earlier, the radius is equal to 1. So now let's just put that in there. So we have x squared plus y squared now equals that r is now 1 and it's squared. Okay. Now, I also know that x and y in terms of sine and cosine. I want to put it in this form where there's a sine and cosine, so I need to put that in there. So I know that cosine theta equals x. I also know that sine theta equals y. So let's just substitute it back up into this and see what we get. Okay, so x is cosine squared theta. So we have cosine. Now, since it's a square, the cosine has to be squared. Notice where the 2 is. The 2 is here and not on the outside of the theta. Okay, that's not the same thing. And we're going to add, and that's plus sine squared theta. And that has to equal r1. So 1 squared is 1. So now if you look at this up here, we have this up here. So we're going to take this and use this for information. So these two added together give you 1. It doesn't matter which order you write the sine and cosine because it's a addition, so that's commutative. But we want to make sure that you usually write sine first plus cosine squared theta. I'm not sure why, but it's always something that we just do and we memorize it that way. So for this Pythagorean identity, sine squared theta plus cosine squared theta has to equal 1. Again, this is one you're going to want to highlight and know. We have to know this, okay? So now what we're going to do is we're going to take this identity and we're going to solve it for sine squared. Now, notice that squared plus squared equals 1. So that's why we're thinking of Pythagorean, because that's how you pretty much found it. If you're thinking about that rectangle, that's what we did, okay? It's just in terms of sine and cosine. All right, so we're going to take what's above. So we're going to take sine squared theta. Throughout this, I'm going to probably use the same color for sine, cosine, and tangent, and what relates to it, correlates with it, so that's more easy for us to see. Okay, so if I do this and I want to solve for sine, I'm solving for sine squared theta. It's just like any other equation. I'm just going to move the cosine squared over. So in order to do that, I subtract both sides by cosine. Okay, and what do I wind up? I wind up with sine squared theta equals 1 minus cosine squared theta. That's what we got here. Okay, let's take the next one, and we're going to solve the next one for cosine squared theta. Same idea. Or to solve for cosine, I got to move the sine over. Sorry, let me write that sine squared theta a little bit better. And one thing you're going to have to do with this lesson is to make sure that you're very clear in your writing. You understand what you write so that anybody who reads it is going to be able to understand it, because a lot of times your work is your answer. All right, so this winds up equaling to cosine squared theta equals 1 minus sine squared theta. All right, so let's fill in this variations of Pythagorean identity 1, which is a sine squared theta plus cosine squared theta equals 1. So all we're going to do is, what is 1 minus cosine squared theta? According to what we just found out, it's sine squared theta. If you have 1 minus sine squared theta, that's going to equal 2 cosine squared theta. This is a variation of what we're doing, of what we've done so far. You don't necessarily have to memorize this. It helps if you already have it in your head when you do it. But remember, you can just do what we did up above and just solve for that, whatever you're looking for based on what you need. Now, one thing about this identity we have, one thing nice about the identity we have of cosine squared plus sine squared theta, or whichever you want, right? Sine squared theta plus cosine squared theta equals 1. You can find these other two Pythagorean identities we're about to do. So if you just know that Pythagorean identity of sine squared plus cosine squared equals 1, you can still find these other ones without having to memorize them. But again, you'll have to do some extra work before on top of the other work you have to do. So sometimes it's best to memorize them, and that way you have them down. You don't have to do that extra work. All right, let's see what it's asking us to do in this next part. Take the Pythagorean identity and divide everything by cosine squared theta. Okay, we're just dividing everything by cosine squared theta. Remember, in mathematics, we can do this because what you do to one side, you can do the other. So, and if you do it to everything, you get to be legal in mathematics. Now, remember, this, when you do stuff like this, it doesn't change the value. It just changes what the equation or the statement looks like, or not, or, you know, so you're never going to change the value of it. But just to let you know, it's still legal. Okay, so now if I think about what happens here, so let's look at this first term. Okay, this first term right here, this is always going to equal 1. Anything over itself equals 1. It's a fraction. So when I want to simplify this, see what this comes out to. Cosine squared minus theta divided by cosine squared theta equals 1. Plus, well, what is sine squared theta over cosine squared theta? Well, that's our tangent squared theta. And that equals whatever cosine squared theta is, which is our secant squared theta. Okay? And now let's do the same identity, but this time we're going to divide by sine squared theta. So again, it's allowed to do. This stuff is legal as long as you do it to everything and every term on both sides. So divide everything by sine squared theta, including one. I highly recommend that you do this step if it tells you divide everything or whatever you're doing to show the work. Again, showing the work is most part of the answer, then just simplifying to that one answer. Showing your work is your proof, saying, hey, I know how to do this. So if we look at this first term, this is going to equal to, that is cotangent, right? Cosine squared theta over sine squared theta is cotangent squared theta. Plus, again, this is a lot like above. Anything over itself equals 1. So this is 1. And then 1 over sine squared theta is cosecant squared theta. So now if you notice, we created 2 new Pythagorean identities, which are going to fill in right here. So tangent squared theta divided by plus 1 is always going to be a secant squared theta. So again, not divide. Tangent squared theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. Okay, so now let's do the next part. It says take the identities above and solve for tangent squared theta and cotangent squared theta. So we're going to take each of those. I'm just going to divide this in half. We have this identity of tan squared theta plus 1 equals secant squared theta. And it wants you to solve for tangent for this one. So if I solve for tangent here, I'm going to have to move over the 1. So let's subtract 1 from both sides. Sorry about that. So we get tangent squared theta equals secant squared theta minus 1. So let's do the other side. So now we want to take cotangent. Oh my goodness, I wrote it wrong. Cotangent squared theta plus 1 equals cosecant squared theta. And we want to solve for cotangent squared theta on this one. So we want to make sure that we are solving for cotangent. So again, move the 1 over. Subtract 1, we get cotangent squared theta equals cosecant squared theta minus 1. Look how that looks like that. There you go. So here we go. So the next one is take the identities above and solve for 1. So we're going to take each of these that we just up here that we wrote originally. So you're always taking the identities, and we're doing tangent squared theta plus 1 equals. This time we're solving for 1. So if we're solving for 1, we want to move over the tangent. So I'm going to subtract both sides with tangent. So I get 1 equals. Now, you cannot change this order around, as in secants must come first, then minus the tangent squared theta. Subtraction is not commutative. Okay, so let's do the next one. Same thing, same was above though. We're going to do cotangent squared theta plus 1, which equals cosecant squared theta. And again, we're going to solve for 1, so that means we have to move over the cotangent. So we get 1 equals cosecant squared theta minus cotangent squared theta. Again, not commutative, so it has to be cosecant minus cotangent. Okay, so let's write the variations of the identities. We have tangent squared theta equals secant squared theta minus 1. And then we have the other part up here where we have secant squared theta minus tangent squared theta equals 1. We did cotangent equals, we got cosecant squared theta minus 1 equals cosecant squared theta minus cotangent squared theta. This one's a little messy. For some reason, cosecant, I have a hard time remembering sometimes that second S. And then when I remember, it's kind of messy when I write it in. Now, didn't highlight these, but again, these are things that you need to know. So make sure that you know this as well as this one. Again, you can get the variations by knowing the two identities above, but it makes your life so much easier if you memorize them. This is a summary of the basic trig identities. You got to know this whole thing. I know we put it all together, but they're all together the same thing. So again, make sure that you have this whole thing memorized. Okay. Let's just do this part like that. All right, let's write these in as we go. So fill them in. Okay, so here's everything filled in. One thing I want to make sure everybody understands that these can be used, these reciprocal identities can be used for are true for what do you call it? True for squares as well. Okay, so now we're going to take this information, all these identities that you have to memorize, and we're going to do some examples. So use the trigonometric identities, to write each expression in terms of a trigonometric function. So we want a single one, okay, single. So another one minus cosine is not, so think of expressions, okay, so write an expression in terms of that. So we want a single expression when we get done. So for the first one, what we want to do when we rewrite it for all of these is to try to change every expression, I'm just going to say everything, in terms of sine theta and cosine theta. So what that means for us is I'm going to take each one, everything that I look at when I'm trying to solve to get that single trig function for every one of these. So I go look at the example. So let's look at example A. Okay. Example A says we have tangent theta times cosine theta. So not every term is in terms of sine and cosine. The first part, or sorry, every factor, I should say. So tangent is not in that term. So we're going to change tangent into whatever it is that we can that's sine and cosine. Well, we know tangent theta, according to this up here, it's sine over cosine. So that's what I'm saying. Change it to something like that. So this is going to be sine theta divided by cosine theta. There's your tangent theta. But we're still multiplying it to this cosine theta. Okay, I'll do this two ways really quick, and then after that I'll probably not. But I want you to understand that with this one right here, if you put this over 1, you can just cancel exactly what's on top and the bottom. So cosine and cosine will cancel. So I will take cosine divided by cosine is 1. I have a common factor of that, and I'm going to make that 1. So when I multiply across the top, multiply across the bottom, all I get is sine theta over 1, which is just sine theta. I don't expect you to do this right here, but definitely, obviously, give the answer. Okay. The other way that you can do this, if you're not a person that cancels, and I highly recommend you get used to this first one because sometimes you get really long fractions. And there's a lot numerator, a lot denominator. So with this next one, the example that I'm showing, so I still have the same thing, sine theta over cosine theta times cosine theta. And I put over 1. But what I can do is I can multiply across the top, and I get sine theta times cosine theta. I want to create one fraction. But again, same thing, I have a top and bottom. This cancels and this cancels to a 1. So I am just still left with a sine theta, which is what I got up there. Okay, so either way. Letter B. Letter B, hopefully you recognize that this is an identity. If I see a 1 with something squared, a trig function squared, I want to look at that. Well, according to my identities, if I have 1 minus cosine squared theta, up here it says, then I have a sine squared theta. So I can convert everything to single trig functions. And 1 minus cosine squared theta is not a single one because there's 2 terms there. So we want a single expression on top. So let's change that, like we said, to sine squared theta divided by a cosine squared theta. We know sine over cosine is tangent, so this just equals to tangent squared theta. Now the work is part of your answer, so I'm circling what the final answer should be as in single term. All right, letter C. Cosine theta times cosecant theta, what does that equal to? So I saw that cosine theta is a sine is one of the things we can leave it at, but cosecant needed to be changed to 1 over sine theta. That's the reciprocal of it. So when I multiply these two together, I will get cosine on top. So if you put this over 1, do you need to? Over sine theta. Well, cosine over sine is equal to cotangent theta. Okay, last example on this page. So we have a tangent theta times a cosecant theta times cosine theta. So let's change this and this in terms of sine and cosine. When we know tangent is the same as sine theta over cosine theta times, and we use a lot of dots more than parentheses, so whatever you like to do, so just know that those dots there. I prefer that instead of a lot of parentheses because it gets to be a little much. Cosecant theta we know is 1 over sine theta times our last one, which is cosine theta. Again, if you need to, you can put that over 1. 3 fractions. Now this is where I'm just going to cancel. Remember, if I have exact same thing as the top as the bottom, no matter how many things I'm multiplying together, as long as they're all being multiplied together, we can cancel. So this sine and this sine both cancel to a 1. We divide both sine by sine theta. And this one, cosine theta over 1, that, okay, equals 1 over 1, which is just 1. Now let me just do another way just real quick for this one. Make sure this is what my second way would be. So I would have the same thing after I changed everything. So I'll write that out. So if you're the one that prefers to multiply across the top and bottom so that you have a single fraction, then you would get sine theta, this is all over this, times cosine theta. I didn't put the 1 in there because sine times 1 is sine, times cosine is that. And then the bottom we have cosine theta times sine theta. Different ways you can look at this. You can cancel top and bottom. But remember, if it's exactly the same on the top, it is the bottom, no matter if this is multiplication, I can switch it around. We know this equals 1. So same thing. All right, here on the last page. Use the trig identities to write each expression in terms of a single trig function. So the same thing we're doing, you're going to use the same strategy as you did earlier. Okay, make everything in terms of sine and cosine. But the thing is that this would be a more, I would say more complicated. Oops, let's spell that right. Complicated simplification. Or a little bit more complicated, simplifying, whatever you want to write there. So it's going to be a little more things that we're going to do. And notice we have a lot of fractions here, and so that may mean more depending on what kind of function we have to work with. So the first one, I have cosine theta divided by cotangent theta. No sine or cosine there at all. So this top one, I'm going to change to 1 over cosecant. That's the reciprocal of that would be 1 over sine theta. I always make sure I have a great big bar underneath showing that it's my division bar, because on the bottom looks like I have another fraction. So cotangent is the same as cosine theta divided by sine theta. Now, different ways you want to look at this. I'm going to do 2 ways real quick. The first one you want to think about is that we know what I call the simpler simplification, as in of this fraction over a fraction. So if we know that if the numerator is the same, these will be canceling out to 1. And then you are left with just 1 over cosine theta, which equals secant theta. Now, if you did not see that, that's fine. But hopefully, you'll, as you do these, maybe they'll pop up enough that you'll say, okay, I want to do it this way instead of the other one. Now, the second way is that we're just used to, this is a fraction divided by fraction. So what we do is you keep the first one, and then you multiply by the reciprocal of the second fraction. So the first fraction stays the same, 1 over sine theta times the reciprocal of the second one. So that's sine theta over cosine theta. So here I have fraction, this cancels with this, they go to 1. And so I'm left with 1 over cosine theta, which equals secant theta. So 2 ways. This is your first way, second way. Okay? I won't always do both, but I just make sure you saw that. Letter B. All right. Again, I see a 1 minus cosine squared like we saw before. This is going to be an identity, which is nice because it makes it a single term. So 1 minus cosine squared theta, we know is sine squared theta. Again, make sure that you are very careful with your writing. Make sure your thetas look like thetas. Your 2, or if you're squaring or whatever, is a square, not a 2, so it doesn't look like 2 theta, because there is a thing of sine 2 theta, and you don't want to get that mixed up. All right, so tangent squared theta is sine squared theta over cosine squared theta. So this is not like the other one where the denominator is the same, because remember, this is technically over 1, so you can't do that. So I'm just going to go ahead and change it to sine squared theta times, remember you're going to multiply by the reciprocal, so multiply by the reciprocal of cosine squared theta divided by okay, so again, I multiplied those and then multiply by the reciprocal. So if I put this over 1, I have sine squares that are the same, so I can cancel those out. So I'll cancel this one, they go to a 1, not just a canceled out. And that ultimately equals cosine squared theta. All right, next problem. So cosine theta is the same, so I'm just going to go ahead and write this as cosine theta. Secant theta is 1 over cosine theta. So I'm going to multiply that 1 over cosine theta. Okay, this is my big bar, so all of that's being multiplied together. So, and then on the bottom, we have tan theta. We can change to sine theta divided by a cosine theta. So in the numerator, you have a fraction times a fraction, since, because remember if you put this over 1. So I'm just going to multiply that together, okay? And if you do that, you will get cosine theta over cosine theta all over our denominator, which is sine theta divided by cosine theta. Okay, there's different ways you can look at this. Hopefully, maybe, but if you're not sure, this looks like it's a 1. You can make it a 1, or you can just simply, if it makes it a little more easier for you to see. I know that this denominator is the same, so this becomes a 1, and this becomes a 1. Okay, and what am I left with? I am left with a cosine on top divided by a sine on the bottom. Well, cosine theta times divided by sine theta is just cotangent theta. So we can change that to cotangent theta. Again, different ways you can look at that. You could have always just changed this to, maybe cosine theta divided by cosine theta times the reciprocal. So we can do that, and then you would just cancel out these to 1 and still wind up back here. Depends on what you like to do. That's just another way of solving that, okay? Letter D. I have sine theta, which is fine the way it is, but cosecant theta is 1 over sine. So let's just change this. Bar here for our division, and then we have 1 over sine theta. Okay, so again, this is over 1 like that, so we can't do canceling of the denominators. So remember what this is actually just the same as sine theta times the reciprocal of the denominator, which is sine theta over 1. So making sure that this does not look like a decimal. That is not. It's a multiplication symbol. And you can put this over 1 if you need to. Notice you can't cancel anything out. So sine theta times sine theta is just like if I have an x times x. That is going to equal sine squared theta. And you're done. Okay, letter E. We have a sine theta times a secant theta times a tangent theta, so I will have to change secant and tangent. So this is going to equal to, sine stays the same. Secant theta is now going to change that to 1 over cosine theta. And we have a big fraction bar here. If you want to, you can put this over 1 to kind of see it. That's 2 fractions. And then on the bottom, we have tangent theta, which is sine divided by cosine. Sine theta divided by cosine theta. All right, so when I finish this top, let's combine the numerator, multiply those 2 fractions. When I do, I get sine divided by cosine all over sine divided by cosine. Okay, so when I look at this is a big fraction, it's called complex fraction, I notice that the numerator is exactly the same as the denominator, okay? So that fraction is the same as the bottom fraction, so if you recognize this, okay, so again, this is anything over itself. Anything over itself equals 1. Okay, So that right here means this all just equals 1. Okay, now let's say you don't see that. So we're just going to take the top fraction and then multiply it by the reciprocal of the denominator. So we will have, so down here is the second way we're going to do it. That's your first way. So we're going to start this over here. Instead of doing this, just looking at it, we're going to take that first fraction, the numerator, times the denominator, the reciprocal denominator, excuse me. And if you notice, I can cancel out as long as it's exactly top and bottom exactly the same. So this sign cancels with this sign to a 1, and this sign cancels this sign 1. So my answer still is 1. So either way you want to do it, it's fine. All right, last one. Okay, on top we have cosecant squared theta minus 1 divided by cosecant squared theta. So hopefully you see that this right here is an identity. And so we can change that cosecant squared theta minus 1 is the same, equals to cotangent squared theta. So I'm just going to rewrite this, cotangent squared theta, divided by the cosecant squared theta. Okay, so both of those are not in terms of sine or cosine, so I'm going to change the numerator and the denominator. All right, so cotangent squared theta is equal to cosine squared theta divided by sine squared theta. And then we're all over the big bar, fraction bar there. And then cosecant squared theta is 1 over sine squared theta. Okay, I see that now the numerators here are the same. So this, denominators are the same. So this sine squared theta cancels with this sine squared theta to 1, dividing them both by sine squared theta. And that just leaves me with cosine squared theta over 1, which is just cosine squared theta. You don't have to do this step here, but I just want to make sure you see where I got it because the 1 on the bottom. Now that's just the first way. So again, I'm going to do it another way so that we can see how you may not see that. So, or you can do this. So we're going to start at this part right here. So this equals to the cotangent squared theta divided by cosecant squared theta. And you saw that it was cosine over sine, all divided by 1 over sine squared theta. Okay, instead of canceling that, we're going to keep the first fraction and multiply by the reciprocal of the denominator. You like to say keep, change, flip. So to keep the first one, we have this. And we're going to multiply by the reciprocal, which is sine squared theta over 1. Nice that these cancel out. They're both being divided by sine squared. And so I'm left with a cosine squared theta.